Lars Fabricius. I'm Danish, but I've lived in the UK for most of my life. So I am best described, if you like, as a Danglish. I live in two parallel worlds. SAV, we are based in Woking. We are basically the sales organization for several Danish district heating technology companies, Danfoss, heat interface units, CHPs, and so forth. We're actually in the process of establishing a Scottish headquarters here in Edinburgh. In recognition, really, Scotland has similar climate to Denmark. Denmark's 5 million people, Scotland's 5 million people. There are links between the governments and so forth. So lots of things going on our side. What I'm here to talk about is really carbon reduction, but on a shoestring. And really sort of it's a personal sort of insight into what's going on in the UK. And it stems from the issue that I see that is the big challenge. I mean, a lot of focus is going on to Northern Europe and how they're doing it, and people get fascinated by the technology. But what sort of where I feel we're going wrong is what's the technology transfer. The technology they have is a manifestation of a culture, of a mindset. But what we're doing is we're bringing in the technology, but not the mindset. So really the point of the shoestring is I like to talk about what is a district heating, call it a communal heating network, and everyone talks about it. This is something that's going to happen, that's going to help us. But I want to talk about actually what I understand, and also where the Danish mindset is. Denmark went down this route 40 odd years ago for historic reasons. So Denmark are much further down, if you like, the learning curve than the UK. And so when I do philosophize about this, the thing that we have to think about is the culture. And another word for culture is habit. So what we are really trying to do is we're trying to change the habit of how we all behave and how systems work in the UK. And it's a tall order. Can we transfer that? That's a question. I mean, you would have thought that China, Beijing could have learned from the Industrial Revolution in the UK 150 years ago and say we've got to be worrying about pollution. It doesn't happen like that. Our kids don't necessarily just do what we tell them. So it's human nature. How do we change human nature? And that's the nub of what I like to talk about. What has been the sort of driving force in Denmark has been money. The Danes Denmark and Scandinavia 100 years ago, dirt poor. Poorest part of Europe. So money is king for them. There's a farmer mentality in Denmark and so forth. So what was the driver to go down these heat networks was simply, is that a cheaper way of putting some other technology into our buildings? So and you can see this is, I've said this is good heat network practice, but this is actually the Danish, if you like, energy constitution, or what I'd call it. And it says, heating systems shall be operated to ensure a satisfactory thermal, satisfactory. And in Danish, that means just enough and no more. And then they go on to what they're more excited about, lowest possible energy consumption and cut out all waste. So the focus is on the cutting the waste and not having overheated, over wasteful buildings that are being consumed. The challenge that we are facing is all this talk about heat networks, and when the heat networks are here and this is going to do this and that for us. The real issue is that a heat network, how do you define a heat network? Well, there's a heat source. It could be 2 apartments being fed off a main system. But any central heating system, building or whatever, is potentially part of a heat network. So instead of saying there is a promised land that some district heating will come in one day, we should be looking at, are we ready for district heating? And by no, we are far from being ready from district heating. We're so far but the issue is that we're looking, in my opinion, in the wrong places. And what we've got to look at is how are we behaving and how do our buildings and our apartments and houses work today? And you can see the point that they're really making here is that on a heating system, you get heat from a central source, and then you pass the return water back. If you send the return water back at a high temperature, it basically means you haven't used all your heat. So by definition, it's wasteful. But all the focus in the UK, because of energy's always been cheap, is on the demand side. Everyone's worried that someone's going to complain there's not enough hot water for the shower, the rads are cold. The focus is very rarely, I've never heard of a facilities manager being fired for using too much. Who just says, well, that's what it's cost because the boilers are efficient, etc., etc. So the real problem is, and similarly I think that works for me is to say, if a building's got a return temperature of 65, i.e. is not really exploiting the heat that it's received, let's say 80 goes into a building, or from the plant room 80 is supplied, and most of it comes back to the plant room, you can compare that to our bodies. And that's why I'm using this. That is basically, the building is like a human being that's got a heart rate of 120 pulse per minute. It's basically hyperventilating, running at far too high speed. We're running a temperature. So any person that went into a GP with that condition, you say, you've got a problem, we've got to sort it. But that's exactly what our buildings are doing. If you've got a return of 65. And I can stand up and say, we know this is the norm. In Scotland alone, we're monitoring about 65 to 70 CHP sites from us. So we can actually see what the return temperatures are. And they are extremely, very high. Now, then I sort of read on the internet and said, what in our bodies, if we're running too high a temperature, too high a pulse and so forth, what does that mean? Thank you. Well, it could be that we're psychologically out of balance. It could be that we're on drugs. But our body has a very sophisticated system to avoid this happening, because if we hyperventilate, we'll keel over as human beings. Too much oxygen circulates around our body. That's exactly what's happening in our buildings. Our buildings are not keeling over, but where they are dying is on their cost of energy being wasted unnecessarily. And you cannot connect a building like that to a heat network. They won't accept it. So what's the point of worrying about heat networks if our own buildings are not compatible? They are not ready to connect onto that. But this is something we can go and do something about now, because it's behavioral. It's the way we look at the buildings, the way we operate the buildings, the way we live in the buildings. That's the nub of it. It's not a technology we need, it's a mindset that we're missing. And you say, okay, let's say that we slow down the flow rates, we run the operation of the building more efficiently in schools, in hospitals, in hotels and so forth. Well, what does that mean? The experience in Denmark is that 30–40% savings. So instead of having high temperature water whizzing around the building all the time and being wasted in overheated corridors or open windows because people, that's the money. So that's low-hanging fruit is in all the buildings we're all living in all as we talk. It's not about future networks, it's about what we're doing now. And there is, there's no person that would dispute any of this, but what there is a clear link is between the temperatures that you operate these heating systems at and the energy efficiency. So the UK is, if you like, addicted to cheap gas and efficient boilers. And so we got boilers that could do 80, let's do 80. Who's going to say anything different? No one's worrying about the cost. And that's part of our whole culture. We've just got lazy. We're just lazy with our heat, essentially. What you won't be able to see it, but the correlation is basically dropping the temperatures that you have to flow at systems, the more energy efficient they become. So that correlation. The UK is really in the middle, addicted to the 80. We should be going down to 60, and even as far down as 50 degrees, and that's possible. And what's going on in the UK is that there are lots of heat networks, but we could talk about district heating, but you can also talk about individual apartment buildings with a lot of flats with a common heat source. That, per definition, is also a district heating or a heat network. The problem with them is that the whole job description is to give us low, inexpensive energy, but if you waste most of the energy just circulating around the building, you're going to end up with very expensive heat, then there's no point in the heat network. We're missing the job description of the heat network. The Danes are not doing it to save the earth, they're doing it to save money. But we lose that in terms of carbon, we've got to do all these things. It's very hard-nosed what we've got to focus on. And so therefore there's a new publication, it's going to be very valuable to the industry. It's coming up from SIBS in the CHPA, but essentially it's about heat networks and the issues and the problems that people are experiencing. So that's going to have a big impact on what, but the emphasis is on temperature and pressure. Just as in our bodies are focused on temperature and pressure, whereas most system designers in the UK think more in terms of flow rates. So the cultural changes with FM, with clients, is consumers, and consulting engineers. It's a holistic, quite radical change that's going to be required. Okay. I've been told I've got 5 minutes, and now my presentation is... Okay, I'll whiz through, but the principles will stay the same. If I quickly go on. One of the key tools is energy meters. It's measuring temperature. So energy meters go into apartments, go into buildings, and one monitors them. But before one even starts worrying about that, if we don't reduce the demand, I see too many people talking about, well, heat networks are going to give us cheaper energy, so we don't need to put energy meters in, but you're just going to result in cheap energy going straight out of windows. So the metering side of it has to be there, and that's draconian, certainly in Denmark. But what's interesting is that in Denmark, what they also do is, if you connect onto a grid with other people, not everyone has the same attitudes, the same values and so forth, but what they have to do in Denmark is you get 2 bills on your energy meter. You get the bill for the heat you've consumed, and then you get a bill if you return your heated water at too high a temperature, you're going to get bunged with a penalty. So you might be charged 100 quid for your heat, and another 50 quid on a penalty. And then after a few months, people start saying, why am I getting this penalty? Say, you haven't balanced your system in your building, you've got to do something about it, you're not being a good citizen, because you're no longer living in your own castle, you're now part of a grid. So most buildings could not go onto a grid today. That's what we've got to focus on. And experiments, as I say, if we shower, I mean, 36 degrees, why do we need 80 degrees on our boiler if I need water to shower at 36? Something's got lost somewhere. And in Denmark, they've taken it down to 50 degrees. 50 degree flow, 30 degree return from an apartment, and you're fine. So there's so much scope in saving in what we do today as opposed to what can happen tomorrow. I'll skip these more technical slides, but the theme is the same. Balancing radiators, domestic hot water systems, all of these things all come back to the question is what's preventing us? What you could say is simple. I think the last slide is probably the most important one to just concentrate on. So in essence, what you've got is these meters focusing on the return temperature will give you a very good understanding of how is the patient. It won't be able to tell you what's wrong with the patient, but if you've got a high return temperature, you've got a patient and there's money to be saved in doing something about it, taking the pump speed down, going in, improving insulation, whatever. That's a more laborious aspect of it, but the money is there. And so the Danes are just focused on that one question, what is the return temperature? And so, really to the audience, if you are not continuously monitoring the return temperature of your boiler at home, or any building you're responsible for, and if you're not focused on that, you're missing such a critical point in actually making your building, basically the low-hanging fruits, they're there to be picked up on. And what we do find is more and more clients are saying, well, actually, some people on a personal level say, this is interesting, and they start to dig into why is their building profile doing this and that. So there's a simple message, but it'll open an incredible can of worms in terms of what kind of a savings opportunity you're sitting on, and at the same time, you're making your building future-proof for district heating. Thank you very much.